Hey guys, imagine this. You're on the International Space Station, looking out the window at the beautiful blue Earth below, and suddenly, a tiny fleck of paint, no bigger than a fingernail, slams into the window at 17.5 thousand miles per hour. That's 7 times faster than a bullet. It could crack the glass, or worse. That's not science fiction. That's the reality of space debris right now. Welcome back to Edgeverse. Today, we're diving into one of the biggest threats to our future in space, the great space debris problem. Orbital junk is piling up fast, and it could make parts of space completely unusable. We're talking about losing GPS, internet, weather forecasts, stuff we rely on every single day. Stick around, because this is serious, and I'll tell you what we can do about it. Let's start with the basics. How much junk is up there? As of 2025, space agencies like ESA and NASA track about 40,000 objects bigger than a softball, but only around 11,000 to 12,000 of those are working satellites. The rest? Dead satellites, old rocket parts, and fragments from explosions and collisions. But that's just the stuff we can track. The real nightmare is the smaller pieces. There are over 50,000 objects bigger than 10 centimeters, big enough to destroy a satellite completely. About 1.2 million pieces between 1 and 10 centimeters. These could cripple a spacecraft. And get this, over 130 million tiny particles smaller than 1 centimeter, like paint flakes and slag, that can still punch holes in critical systems. Think about it. These things are zooming around at orbital speeds, up to 28,000 kilometers per hour. A collision releases energy like an exploding grenade. Even a paint chip has cracked ISS windows in real life. Where does all this come from? Mostly from us. Fragmentation events, like when satellites explode from leftover fuel or batteries, create thousands of pieces at once. Remember the 2009 collision between a dead Russian satellite and an active Iridium 1? That alone added over 2,000 trackable fragments. Or anti-satellite tests by countries. Those are deliberate debris creators. Then there's mission-related junk, stuff we release on purpose, like lens caps or bolts. And over time, satellites degrade, paint flakes off from harsh radiation and temperature swings. Most of this junk is in low Earth orbit, where we put our most useful satellites, comms constellations, Earth observation, the ISS. Some bands are so crowded now that debris density matches active satellites. Rhetorical question, how long until something bad happens? That's where Kessler Syndrome comes in, named after NASA scientist Donald Kessler, who warned about this back in 1978. Picture this. 2 objects collide, creating a cloud of debris. Those pieces hit other things, creating more debris, and it snowballs. Once it starts in a busy orbit, it becomes self-sustaining. Debris generates faster than it falls back to Earth naturally. Are we there yet? Experts say yes, in some orbits. Even without new launches, models show the population would keep growing from collisions alone. We've seen rising collision rates, and in certain altitudes like 800 to 1,000 kilometers, it's already at critical density. We're on the edge, guys. A big solar storm or one bad collision could tip us over. What does this mean for us down here? Everything. We depend on space more than you think. Satellites handle global comms, your phone, internet, TV, weather forecasting. Without polar orbit sats, we'd miss hurricanes and storms. GPS, not just navigation, but timing for banks, power grids, everything's synced. If Kessler hits hard, mega constellations like Starlink could get shredded, blacking out internet in remote areas. Lose weather sats? More lives lost to unprepared disasters. Degrade GPS? Chaos in transport, finance. Economically, billions at risk. Operators pay huge insurance. Avoidance maneuvers cost fuel and shorten satellite life. And the market for fixing this, tracking and removal, is growing fast, but it's money we'd rather spend elsewhere. So what are we doing about it? First, prevention, better design. Satellites now often have deorbit plans, burn up in 25 years or less, or move to graveyard orbits. Passivation, drain fuel and batteries at end of life to prevent explosions. Collision avoidance. Many sats maneuver automatically. Compliance is improving, especially commercially, thanks to guidelines from UN, ESA, NASA. But it's not enough. We need active removal. Cool tech is coming. robotic arms to grab dead sats and deorbit them, nets to capture tumbling junk, harpoons for piercing and towing, even lasers to nudge debris lower with ablation pulses. Companies like Astroscale and ClearSpace are leading demos. ESA's planning missions to grab old payload adapters. It's risky, navigating a debris field to catch something spinning wildly, but essential. Policy-wise, we need binding international rules. Mandatory deorbit, shared tracking data, no more sat tests that create clouds. Paradoxically, even as we get better at mitigation, launches are exploding, mega constellations adding thousands of sats. The next decade is make or break. If we deploy responsibly, we can manage it. If not, some orbits could be lost for generations. Guys, space isn't infinite. It's a shared resource we're trashing. But it's not too late. A sustainable future is possible. Cleaner orbits by 2050, with removal ops routine, strict rules everyone follows, and space open for exploration. Moon bases, Mars missions, all safe. We need action now. Support policies for sustainability. Push companies to be responsible. What do you think? Is Kessler Syndrome inevitable? Or can we fix this? Drop your thoughts in the comments. Best ones get pinned. If this blew your mind, hit like, subscribe for more space stuff, and turn on notifications. Share with a friend who loves space. Thanks for watching. See you in the next one. Clear skies.